I will talk about building data access library in functional language, particularly its F#. How it begins. Some years ago, I decided to learn F#, and simultaneously, since I was not experienced functional developer, my second goal was to improve my FP skills. In my opinion, the best way of learning new things is to create some small project, implement something that is small, but still significant. Maybe something usable for another people. So I launched the project, and it is finished and is in use now. And it is a web application, so and has a backend in relational database, and it was fairly easy to find a web framework for it. We had some excellent functional frameworks like SafeStack or WebSharper. But I had a huge problem choosing database access library. What was the problem? What is problem with existing tools? So there are, when working with .NET, in .NET platform, there are some obvious choices. When we choose data access framework, we always consider entity framework first. It is big, full-blown, feature-rich, Microsoft-baked object relational mapper. And in this case, this was not a very good choice because of object-oriented mindset. The biggest obstacle was, in my opinion, mutable object graph, because it has a huge impact on the whole application. And to program functionally, I would have to do some abstraction layers, even corruption layer around it. So I think that since it was a kind of learning project, it was important to choose tools that encourage me to use the paradigm, and this tool rather hinders me. So another thing that it is really complex, has many features that are useless for functional programming, like change tracking or lazy loading. So I decided to give a chance another tool. The next I try was Dapper. It is another quite obvious choice. It is very small, very fast, very simple tool built by Stack Overflow team. Using this tool, we specify our queries as strings, and it generates code that materializes our objects. So it transforms result set to some records. It's a nice tool, and it would be much better choice than entity framework for functional program. But there was one problem. Actually, specifying queries as strings has its advantages, because you can create you can use any construct that exists in SQL. Nothing limits you. And you can, for example, generate your queries. There are strings. But it's double-edged sword, because any typo in your code, in your SQL code, results in exception in runtime. So you have no static checks. And since F# takes static typing very seriously, it was not comfortable to have such a big gap in it. So I decided to try yet another tool. Another was F# Data SQL Client. And it is a type provider, a quite interesting mechanism in F#. It is something a little bit like macro. It allows to generate code in compile time. And this tool allows to generate code from queries that are specified as strings like Dapper, but they have to be literals, so it's compile time tool. You cannot generate them anyway. And at the first glance, it looked like Holy Grail, because you have queries specified as strings, so simplest possible way, and everything is available. And simultaneously, everything is statically checked. But when I started to code some examples, so it seems that it's not so good, because actually the tool has almost no modularity, and it is quite common for type providers. Very few possibilities of configure these tools, no custom conversions, and it is Microsoft SQL Server only. So I decided that it's not a good choice. You know, in functional programming, we love pure functions. They are impossible in database programming, so we need something different, something like control of side effects. None of these tools gave us something like control of side effects. It's nothing strange in case of Entity Framework or Dapper, because these tools were not mentioned to use in functional programs, but F# Data SQL Client should do something with it. So, and another reason was some, in my opinion, important insight. Every time we read about software architecture, there is a very important thing like separation of concerns. And of course, data access is one of these concerns. And the common advice is that it should be separated in some layer or component or service or something like that. But data access tools are not opinionated on it. They allow us scatter data access code around the code without any limitations. My idea was that maybe if we make this advice of separating data access code, maybe if we make it a constraint, we will be able to build something that has some unique features, some new value. Actually, I even found the tool that was based on such assumption. It is from object-oriented world. Inside database is a tool in which you define your database API using, you simply define an interface. Your data access routines are methods of this interface. And you decorate these methods either with stored procedure names or with plain queries, and it is the only way you can express your queries. So, and when you have this interface, the tool generates all the heavy lifting for you. So it generates all the data access code or translations, mapping, and so on. And I started to think that maybe it would be a nice idea to do something similar, but using functional building blocks. And SQL Fan, my library, is something like that. It's inspired by this tool, but code looks so different that nobody would guess that it is based on it. Okay. So the first important thing was to decide what actually are these building blocks, so foundations. When we have a particular query, how should it be represented in functional language? So queries take some parameters, return results. Sounds like a function. So I decided that in my library, queries will be represented as functions. Of course, we need a little bit more parameters than regular query parameters. There are some technical ones like connection to database, sometimes transactions too. Actually, I decided to put connection and transaction together to one data context object, which is our connection with possibly with transaction state. And functions representing queries cannot have all possible parameter types we imagine, because they have to, it should be possible to map these function parameters to actual query parameters. So we will have some limitations, but of course simple values are possible. They will represent various kinds of keys. Complex values like records, of course they are important because it's nice to have record type to insert to a database or to update. Some mixes of one with another, either with tuples, like here, or by carrying. So, and it is almost the whole set of possible parameter types. There are another ones that can be achieved with extensions, custom conversions, etc. For example, lists of simple values or even lists of records are possible, but not in a standard solution. What result types we should support? Of course, some queries don't return anything because they are updates. Simple values, for example, the key value after insert, or some aggregate calculated from a database. Complex values as records. Sometimes we read records from database, simple value lists, of course, and records lists. So it is particular set of correct result types. Okay, and the most important thing was how such data access function should be implemented. The obvious first choice would be to just write a signature and call some API function inside. But as I said about Dapper, Dapper does exactly this, but there is no requirement of defining a separate function. But such a solution would have the same drawbacks as Dapper has, would be stringly type. And Dapper already exists, so there is no reason to write another one. I think this one was the crucial idea in building my framework. Instead of defining function, just define variable that is function type, and initialized it by calling a function that generates data access function in runtime. In .NET we have excellent tools for code generation. It can be expressed in more readable way too, because F# type inference allows us to do it this way. It's quite readable, I think. And what this SQL function does. In .NET, in ADO.NET, we can call the query in schema-only mode. It means that no data will be read, but the call will result with empty result set with proper columns and proper types of columns. So it is the good starting point for code generation. And we can use excellent system link expressions tool to generate code. It is the library that allows to create abstract syntax trees and compile them. So it is high level, quite high level mechanism, very useful. During this code generation phase, we have to generate all type conversions or all type checks and so on. And if something goes wrong, we have exception, for example. So, and it is a simple, straightforward way of validating our data access functions. Funny thing is that this function doesn't even need to cache the generated code, because it is immediately assigned to a value, to a variable. Then we are placing our data access functions as variables in a module. What is interesting about F# modules? If you first time, when you first time access the variable from module, it is instantiated. Sorry. But all other variables of a module are instantiated too. What does it mean? It means that it's enough to write one very simple test to have whole module validated. if something goes wrong in one of functions in a module, we will have exception and test fails. So it gives us some, I think it is quite good equivalent of static check. Maybe it's not as comfortable as real static check, but it gives the same level of confidence, just in my opinion. But I have written some code this way, and refactoring was fearless. Okay, to summarize, strengths of the solution. The first one, since we write queries as strings, we have all possible SQL constructs available. Another thing, we have semi-automatic validation. It's very easy to validate our code, and we have equivalent of static typing. And performance is quite good, because we use reflection, but only in code generation phase. So it's one moment that we are doing it. So the only problem is that it's not functional. So we have to do something to make our solution functional. And when I was writing it, I was really beginner in functional programming. So it was quite a big journey for me. So we know that data access is side effect because it's interaction with external world. So we cannot have pure functions that access the database. But why do we love pure functions so much? There are two main reasons. First is that they are easier to reason about than impure ones. And the second reason is because they compose well. So actually, I knew that the problem of side effects was solved in functional programming years ago, and it was easy to find a solution. Actually, Haskell has I/O. Everything that causes side effects has to be wrapped in I/O monad. We have some equivalent in F#. It is async, so more technical name. And it seems that it was enough to make all these data access functions, to make this mechanism of building data access functions to support async. So it's nice, but it's not enough. We have another problem with doing things. The problem is that we have to manage some stateful object when working with our data access functions. It's database connection and transactions and so on. And it breaks our composability, so it's important to do something with it. I quickly realized that the passing connection to data access functions is kind of the more general problem of dependency injection. So I started to research how should we manage dependency, how should we implement dependency injection in functional programs, and results were strange because it's quite serious thing in object-oriented programming, but the impression was that functional programmers don't care so much about it. The most common advice was, it's just, who cares? It's just a parameter passing. So it's easy. Actually, it's true, but it's not so easy. It needs some explanation. And another one was to use FreeMonad for it. Even some Scala database frameworks use FreeMonad to work with side effects. So I even tried this solution, but it was overkill, especially in F# because its type system is not strong enough to work with FreeMonad. So I gave a try parameter passing. So how to do it? First idea was to that if we have a function that has some dependencies hard-coded, we can replace them with parameters, and then we have something like two kinds of parameters, dependencies and regular parameters. So we can then, when we need to resolve these parameters, we define another module and define our function again by binding these parameters. So in this case, dependency injection is just partial application. And it works nice, but not for stateful objects. It's good. It's perfect if our dependencies are pure functions. Just we can use them. If dependencies cause side effects, we can make them async, and then whole our dependent function should be async too. It's okay, it works. But when working with stateful objects, we would have to do some kind of singleton. It's awful. So I think it never can be implemented this way. And I realized that I can do it another way. Instead of this kind of dependency, instead of putting it as a leading parameter, just make it, just move it at the end of parameter list. It gives some nice possibility. We can define function that manages this parameter. This function, let's name it run, takes function, takes one argument function. That this argument is a database connection, calls this function with this argument, and then destroys it. So it manages life cycle of our connection. And the solution is to call our dependent function with regular parameters, and the result is a function that with one parameter that is the connection. We can pass it to run, and we are done. There is a small problem with calling more functions on one open connection. We can just define the function that groups them. It can be even Lambda. But once a day, I realized that my one argument function fulfills laws of monads, and effectively it is reader monad. The funny thing is that I read about reader monad earlier, but before doing all these discoveries, all these investigations, I was unable to match it, to understand its significance. So my brain was not trained enough in abstractions. So maybe it's better now, I don't know. Okay, I implemented some computation expressions because we program with monads in F# using the mechanism that is known as computation expressions. I don't know why they named it this way in Microsoft. Probably they thought that monad term is scary. I don't know, but I did some mix of async and reader and named it asyncdb. The nice thing about F# implementation of monadic computations is that I can still have it a function. I don't have to wrap this object to anything because monad functions like bind and return are implemented in separate object. Okay, and now our computations looks like this, quite pretty, and it is quite extensible. We can, for example, quite easy define function that wraps the computations in transaction. Okay, next thing. To summarize, the whole dependency injection stuff could look like this. We replace direct calls with parameters, but if our dependencies are data access functions, we have to perform all computations in asyncdb expression. Then we define module that is composition root when we bind this function and have final dependent function. And then in some place we call it with regular parameters, then pass to run function, and we are done. Okay. That was the time I started to think that my framework is mature enough, and I started to implement my side project. And I quickly realized that I'm writing a lot of repetitive code. The problem was that we have different structure of our data in database and from library and in memory, because we have flat sequences of data as a result of our queries, and we like hierarchical data in memories, something like aggregates. So we have post, but we need to have some comments with it, or some tags, or something like that, and it's hierarchy. So how to solve this problem? Fortunately, in .NET, in IDEO.NET, we can call more than one SQL query in one round trip. We can write some queries separating with semicolons, and if we if we execute them, we have one result set with many results. And considering that our SQL functions can manage it and create some tuple of results, we can solve this problem with function composition. So we have simple lambda that glues, combines these results some way. Of course, it was only for showing the idea, because here there is no all this async DB monad, but it's only little bit more complex when using it. We just have to. We just need a map over this monad. Everything works as a charm. So there are, of course, much more complex cases. For example, we can have list of parent objects and list of child objects, and want to combine them some way. And if we only have IDs in memory objects, we can easily match them together. So parent objects should have a key, child objects should have parent key, and all of us is able to write the code to match them. But it's still a lot of code. I was working with my side project for some time with this kind of functions, but it was uncomfortable for me because there were so much dump code. I realized that it's so repetitive that it's possible to define some conventions, and basing on these conventions, this code can be generated. And I just did it. And after providing this, implementing this code generation, code is much more concise. It can be even more concise thanks to F# type inference. So what's next? This join function is able to combine two results. What if we need more results to combine? So I think it was one of lessons of functional programming to do something composable. I defined an operator that allows to compose more joins to handle more results. The operator works this way that first two results are handled by first join, and its results is taken as is passed as a first parameter of second join, and then another result is used. Having this operator, we can combine arbitrary number of joins. And not only joins, because join is most commonly used construct, but we can do another transformations too. For example, we can do some join in our query in SQL, and we have some denormalized result, and then group this this result by first record to make it hierarchical. So, after that, I thought that I have really major framework and started to do some experiments. For example, we have, when we are looking at various data access tools, they usually have some give us some possibilities of making CRUD operations easier. And I did some experimental solution just to check if it is difficult to extend my framework on something. So the idea was that we define a record, and having fields of this record, we can use reflection to read them. We generate insert statement, update statement, select by ID statement, even delete, but we don't need record for it. I think it took me approximately 2 hours. So it's really easy to extend, I think. It's excellent feature. Of course, this CRUD is more like experiment than full-blown solution. You can do it much better than this one. But it's a good example. For example, you would not be able to do something comparable with type providers, having, for example, ready-to-use type provider and so extend it. It's impossible. Okay. Okay. Last important thing. There is one sad truth about SQL. Query optimizer are brilliant, are really amazing tools, but there are situations in which they fail with selecting indexes. The one simple case is if we have, for example, some complex criteria, and some parameters can be set and some can be null. And we can implement our query using null comparison and OR. But in this case, optimizer will not use index. To make such a query efficient, we have to generate it some way. And how to do it? But because the tool I described to you doesn't allow to change the query structures according to parameters, because when we are defining query, we have no parameters. So how to do? Actually, we have to break some rules, but it's possible. First important thing is that we have to define criteria as record of options. In record fields are matched by name, so they are not treated positionally, and there is no problem that some of them doesn't exist. Okay, everything. Only one thing. Okay, we can generate. We can use some template, and in this template, we can change our query according to nullability, optionality of our parameters, then we can clean up the template from remaining placeholders, generate, and in this case, memo is this query. It should be cached here and execute it. I even defined a module for templating and provide some nice helpers, so it can be implemented. The code can be quite pretty. Okay, and there is another solution, and I will not describe it because we have no time, and it is worse. It's interesting, it's very sophisticated, but the first one, which is very obvious, is better. And that's all. I've not covered some things, but I probably will have no time to describe them.
Okay, so let's give a warm round of applause to Jacek. Thank you for your presentation. It was really great. Unfortunately, we won't have time for Q&A, so if you have some questions, please do reach out to Jacek during the coffee break that we have right now. Thanks again. Once again, round of applause for Jacek.